So in the last video, we started talking about how rainbows form. And as we discussed, the sun will have to be behind you over here. It'll have to be a lot of water, big water droplets over in this portion of the sky. I've drawn a huge water droplet here for the sake of my illustration. And here'd be you looking down on the ground. And of course, you'd be sort of be looking in this direction. So the sun is always going to be behind you for rainbows. And as we discussed, a light ray from the sun travel all the way across the solar system into our atmosphere, into that section of your sky like this. And we know that when light goes from a very thin medium like air into water, it's going to refract. But dispersion or separation of light according to its color is part of the refraction process. And so that's definitely going to happen in this interface. And also what we know is that blue is going to bend more than green is, and green is going to bend more than red is. So let me say that again. At the interface here, blue will bend more, red will bend the least, green will bend somewhere in the middle. So let's get our colors out here and draw what's going to happen to the blue components of the ray. They're going to bend the most like that. When they refract, red won't bend as much, the least in fact, green will bend somewhere in the middle. So believe it or not, this is the beginning of a rainbow, is the dispersion between air and water, or the dispersion that happens when light goes from air into water, which is what the raindrop is made out of, will immediately start separating the colors. And so you could just label the drop here. You're already seeing the reason why it's separated here is none other than good old dispersion. And of course, what dispersion is, the index refraction depends on the wavelength. So there you go. All that technical stuff is right there in the raindrop. Now, of course, what happens is the light here that's in the raindrop can certainly continue on. It'll go from the water, which it's in right now, out into the air. It can definitely happen like that. So the red will bend a little bit and sort of leave the raindrop. The green will do the same thing, and the blue will do the same thing. They'll sort of refract again and just leave. Unfortunately, we don't see these rays because we're standing way over here. But is it possible that someone over here could see the rainbow from the other direction? Like maybe they're standing over here or in an airplane or something, seeing these rays. And the answer is no, they won't, because if they're looking in this direction here, they're also looking towards the sun. So although the dispersion is happening and the rays are there, the sun will just bleach all that out. That's why it's so important for the sun to be behind you, so the sun won't dominate the lighting scene, okay? But of course, what else happens in here is there's an interface here, so there's going to be reflections as well. And so the light's rays are going to, these are the refractions that went out and continued along the way, but there'll definitely be a reflection back. So you know the light always reflects and refracts when it hits the surface. So what will happen, the red will bounce down like this. The green will sort of bounce down like that. And the blue will sort of bounce down like that. Now, what are you talking about bouncing? Well, I'm literally talking about the bouncing law that we discussed. You could literally draw a normal to the rainbow right there, a normal to the rainbow right there, a normal to the rainbow right there, and just observe the law of reflection, that this angle in here is equal to this angle in here for red, this angle in here is equal to this angle in here for green, and same with the blue for that angle and that angle. It's just the good old law of reflection. So there's just nothing, that's the easier one, in fact. That's just the bouncing law. So everything that you sort of see in here at this interface right here, that's just the law of reflection. Pure and simple, okay? Then what you get, of course, is the light is going to keep going because we sort of have the directionality. It came in this way, refracted, bounced back, so now sort of going in this direction here, sort of right to left, and the light rays are now going to leave the rainbow. Or excuse me, not leave the rainbow, leave the water drop. So the blue will come out like this, the green will come out like this, and the red will come out like this. Okay. So my sort of orientation of all the things I need to discuss the rainbow aren't quite in the right position, as they never are, but you could see my point here. So let me just redraw the position of the person. Let's say maybe the little person is standing just back a tad bit here. So everyone can see the rainbow from different perspectives, say all over the city if you want, but just for the sake of having you see, like this blue ray would sort of get near the person, maybe go into their eyes, the green would as well, and the red would as well, all sort of making it go into this person's eyes. So of course, these colors here are basically the rainbow. You can see the color separation. And I'm pausing here because there's a little problem. it looks like the way we've drawn this here is it looks like we have the blue on top and the red here on the bottom, because this is definitely all correct. This is how it comes out of the water drop. Blue on top, red on the bottom. But I thought we said when we see rainbows here, back in the earlier video here, that the red is on top and the blue is on the bottom. So there's something a little bit wrong with that, okay? And I will address that in the next video, just a simple fix-up.